Hi, my name is Andy Needham. I'm a freelance senior motion designer based in London, UK. Thank you to Maxon for including me amongst this wonderful lineup of speakers. It is always an honour and a pleasure to have this kind of opportunity. I've worked with big brands, startups and charities, and throughout I've developed my craft both technically and artistically. The type of work I do has meant I've become skilled in a range of software, but my main tool and go-to for 3D has always been Cinema 4D, and I'd like to take the opportunity now to play my current showreel. In addition to client work, I have a background as an educator. I've been making training since 2014 and have created quite a lot of courses in that time for LinkedIn Learning. My courses are largely based on motion graphics techniques using After Effects and Cinema 4D, and learning the software through projects and smaller exercises. Recently, I've worked with the Grayscale Gorilla team to create some training for Cinema 4D R21, covering amongst other topics field forces. I'm also a consultant and collaborator for Created, a company based in London. The idea behind all the courses at Created is to bridge the skills gap between young creatives and creative employers. Online, you can find me everywhere with the handle I'm called Andy, and I'm most active on Instagram, Twitter and LinkedIn. So today I'm going to be talking about how I'm embracing code and Cinema 4D, and I'll explain why I'm using Python more and more in my workflow. And first, I'd like to talk about a recent commercial project. Now, before I explain what it was all about, I'd like to show you the final result. Working with a small team at Coffee and TV in London, I was brought on to assist Dexter George and Steve Waugh to work on a couple of shots for this fun commercial for Dreams. We used Cinema 4D in conjunction with Arnold Render to make a commercial for a bed look like an iPhone spot. I was tasked with completing the animation for the zero gravity shot and some other bits. And you can see here the bed is very detailed. This was modelled and textured by Vladimir Venkov and need to be animated in a really specific way. So with so much detailed geometry, I immediately thought that deformers would be the way to go. Working with deformers allows you to adjust geometry in a procedural, non-destructive way, and the geometry can be manipulated with ease. There's usually an alternative method that will produce the same result. So let's just take a look at this scene in Cinema 4D. So this is the original file, and I don't have Arnold installed on this system, so you'll see a few tags here that have question marks in, but don't really worry about those. What I'm looking at here is just the shot, and you can see we've got the bed, pretty heavy geometry, being animated in this very kind of specific way just to show how the bed moves. So my thought process for this was to turn to a spline deformer. So it meant that we could use a certain set of splines, one flat spline and then a deformed spline that would show the final curved position of the mattress. In the actual project I used a spline deformer. You can come over to the deformers menu here and you can see there's quite a few for working with splines, but this was the one that I used. And what that will do is it will take the original spline, so this is the flat version, and then another spline, the modifying spline. And now let's just take a look at these splines in another scene, because it's very important to have a particular thing in place. So if I just paste those into a new scene and switch over to point mode, let's just zoom in here. Take note of the point count in the left hand side here. So I press Command A, and let's just see, we've got 5 points on this spline. I'm just going to come over and select the mattress curved spline, press Command A, and you can see indeed we have 5 points. So coming over to one of our orthographic views, let's just look at the front. We can see here that if we have both of them selected, we want to basically, match up these points so that the morph is going to be correct. And so that's the key really to this. So we'll now switch over to back to that file, and so I'll just come down to this mattress 2 deformer. Once the splines are in place, the next thing to do is just to manipulate the shape value. And as I scrub through the timeline, you can see that this is just moving up. These points are moving up. So now we're getting the fully deformed spline. So at the top, we're looking at the full modified spline, and at the bottom, we're looking at the original spline. What I wanted to talk about is the fact that there's always another way of getting to the same or a similar result. And so if we just switch over to a start scene that I have here, I actually modeled a simplified version of this bed, and it's still going to work for our needs. If I just come over to my layers and just solo the splines, you can see I've got a flat spline and a curved spline. They both have 8 points, so slightly different from what we had before, but they should still work because the points match. So the deformer I want to use is the spline wrap deformer. So I'm going to add that to the scene, and then I'll bring it in to the bed animated section here. And as I do that, you can see the box, it kind of modifies itself to the bounds of the geometry. So we're including the pillows in this as well. That's why it's slightly bigger than the mattress. This only takes one spline, so we can't just drop in the flat spline on its own. We need to make the flat spline have information about the curved spline, and then we can just bring that in. So we do that by using one of the rigging tags. If we come into the rigging tags here with our spline selected, we can choose a pose morph tag. This is such a powerful tag. It allows you to mix different properties. We're going to focus on points. So if I check on points, what we have is 2 poses here. Now the base pose is simply what we're looking at here, this flat spline. What the pose morph is expecting us to do is actually modify that spline. So we could take the points and, match them up with the curved spline, or we can just delete this and then bring in our curved spline as a little target here, a morph target. So it's going to ask you this question: is it going to be an absolute or relative target? Now, because I know that I don't want to actually go beyond the bounds of this spline, I don't want to kind of push the points too far or beyond where they're set currently. I want it to be an absolute target. So with that done, we now have a base pose, which is our flat spline, and then the curved spline is the absolute target, which we're going to animate to. So let's just come back to our layers and solo the splines again. If we click on animate, we can now manipulate this property, and you see that we're changing that flat spline into the curved spline as we manipulate the slider. So now we have one spline that we can feed into the spline wrap deformer. Let's just bring that in. Okay, so immediately something is happening that's not desirable, but it's all easily fixable. What we need to do is be mindful of the axis that our geometry is pointing on, and it's the Z axis. So we need to swap this over from the X to the Z. That should fix things up, but we're coming into another problem here. Now let's just adjust the sliders down. You can see when the spline curved is at 0, everything looks fine. But if we bring it to 100% or even beyond 30%, it starts to flip over in that same x-axis kind of thing. So it's kind of going that way. We can fix this on the spline wrap deformer. Just come over to the rotation. Let's just increment this by 1. And now we've done that in the x-axis, and that solved that problem where it was flipping over. So let's just manipulate the slider now and just see if we've got any issues. So that's looking good. So we can just come back and we're on frame 0. We can just record the slider at that point, which is the same as just, keyframing the property. Come over to frame 90. Let's bring this up to 100%, and yeah, we'll set a keyframe just like so. So if we just come over to our cameras and look through our previous camera, we're kind of getting something similar to the shot. And as you see, we now have the bed being manipulated using the spline wrap. So that's what I love about working in Cinema 4D. There's always going to be another way of solving a problem, and the tools available to you just allow for that creative exploration. So let's just take a look at the commercial one more time. So now we're coming to the why part of why I'm learning Python. I don't have a computer science background. I'm definitely more of a tinkerer. I have some past experience with other programming languages, but I'm drawn to Python scripting in Cinema 4D because I like to automate repetitive tasks, and Python is very useful for that. So I'm learning it so that I can build tools, and Python's just this universal language, and I can transfer any skills learned in Cinema 4D to other applications. When you're first starting out, learning a programming language can be a bit daunting, but my approach has been based on a few key areas which I think I can, if I can pass them on to you, it should help you get started. You want to start learning a bit of Python, certainly not inside out, just enough to kind of get yourself comfortable, and then pick apart the SDK. There's lots of examples and some really good resources available online as well. Whenever you're doing a Google search, just put C4D Python in front of any question you have and you should get to the result a lot faster. So here's the official Cinema 4D Python documentation. Check out the learning resources section. It's so useful. And also the examples that are available on GitHub. Now there's a few Cinema 4D Python essentials that you should be aware of, and it should help get you over that really frustrating period. It doesn't go away. It comes back, but I feel like I've got over that initial frustration and just sort of banging my head against a brick wall. So the first one is just know what op means. That's where the script is running from. So op is the Python tag, the Python generator, things like that. If you know where the script is being run from, you've got this anchor point. From that, you can navigate the hierarchy and get objects. And this is super important because once you have an object, you can get data about that object. You can make changes to that data, set it, and return it back. So in a nutshell, all we're doing is getting information, changing it, and then sending it back. So let's just take a look at a practical example. And so I'm going to create a sphere, and I'll create a floor object as well. And you can see that the sphere intersects the floor. Normally we'd need to move this up on the Y position by the same amount as the radius. So let's just kind of quickly script that. I'll create a Python tag. It's in the programming tag section here. That's on the sphere. And we're going to move this expression editor over to the side. And what I also like to do is get the console up just to see any errors and things like that. So I'm going to put that underneath here, and we'll just clear out the console. I'm going to just find the sphere now. We know that OP is assigned to the Python tag. So we just say, OP, what object are you on? Get object. and then we'll just store that in a variable called obj. And we can just print that just to verify what's going on. So if we compile, you can see it's a base object called sphere. Great, so we know where we are in the hierarchy now. Now what we need to do is store some values. Maybe we can just say radius equals this property. Now, how do we get this property? You can actually just click and drag and drop it from the attributes manager into the expression editor and just drop. And what we need to do is just change where it says sphere to be our object variable, because that's what we've called the sphere. So next we just want to say, well, this Y position, and we need to change this from sphere to obj. This Y position should simply be the radius. And once we compile and execute, you can see that the sphere jumps up onto the floor. So it's on the ground there. And what's cool about this is we can just come into the object tab and manipulate the radius, and it just sticks to the floor. By no means is this perfect, but it's something that's kind of working, and it's relatively simple to do, and it's a kind of prototype for something further. So my processor approach to scripting is as follows. Set a goal. I mean, without a goal it can be pretty aimless and frustrating, and you need to give yourself a few quick wins in order to keep progressing. Then just lay out the building blocks to achieve the goal. You can search the SDK or Google answers to questions and get that prototype in and just start testing it. My first ever Python script was to create a null object and just put an espresso tag on it. And this is a really good way of starting to just find something that you do all the time, like applying a tag to an object or creating an object with a certain set of parameters and script it. So I gave myself a quick win. It feels really good to save time on these repetitive tasks. You can see I'm just going through the process of actually creating the espresso tag on the object, and with the script it's just a simple click. Moving on, I've always been interested in how mathematical formulas can produce such kind of beautiful results, and looking at this phylotaxis example, we can see that it's the study of the arrangement of leaves and of seed heads in plants, and it's really easy to create in MoGraph using the golden angle of 137.5 degrees. So in this scene, I've got a cloner cloning some spheres, and to make this a bit easier to see, I'm just going to change my layout over to the startup layout, just reset that. So to get this Fibonacci spiral or phylotaxis pattern, we work with the count, the radius, and the end angle. So what we need to do is take our count, which is currently 100, and go into the end angle and type in 100, and then we're going to multiply that by 137.5. Now when we do that, seemingly nothing really happens, and what we have to do now is use an effector to get a gradual change from the center outwards. So the perfect effector for that is the step effector. Let's make sure the clone is selected, and we'll come into the MoGraph menu here. We'll find the step effector over on the right hand side, and I'll add that to the list. I don't want to affect the scale. I'm going to turn that off. I'm going to turn on position, and I want to come back onto the cloner and just take a note of the radius value. So it's 500. So we need to create some kind of offset here. And what we need to do is give this a negative offset. In fact, if I just slide it one way, you can see it's starting to happen, but the effect is happening from the outer radius here. So we need to come back in, which is why we're using a negative value. So if I slide this back in the negative, now you start to see that it's forming that familiar pattern. So I'm going to type in minus 500. And this is looking good, but in real life, the pattern has a gradual amount of scaling as well. I like to have the control as a separate effector. So I'm going to use another step effector to do the scaling. So I'm going to grab one of those. It's already set up in scale mode. I just need to type in minus 0.9, and this is looking pretty good. Let's just bring this down. Now, what we need to do with the step effector is you come into the effector tab, and this is where we have a bit more control over the effect. So by manipulating this spline, I'm doing the position at the moment. You can see we can bring things a bit closer together, and we could do the same with the scale as well. We can just adjust that. Now, if I wanted to make any changes, I'd need to come back onto my cloner and say I wanted to now increase my count to like 1,000. Well, I need to then do that sum again in the end angle. In this instance, we can probably just get away with putting another 0 at the end, and that gives us a pretty decent looking result. But then maybe I want to adjust things like the radius and things like that. Well, I'll definitely have to come back onto my step effector, come into the parameters and start to find that value and adjust it accordingly. So there's a lot of back and forth, and it kind of slows the whole process down. So it would be good if we can script this or automate this process. So I'm going to grab these effectors and just bring it into this version 1, and we'll just turn everything off there and turn on version 2. So let's just see what we've got. So we've got our cloner with the sphere. We have a position step effector, and we also have a scale step effector. And let's just leave these on for now, and we'll just come and look at the Python tag. So on the Python tag, I've got some user data controls. I've defined an angle and the count. And this just means now that I can adjust the angle, adjust the count, and start to see some really cool and interesting Fibonacci spirals. We can combine this look with other effectors and start to create some really fun looking animations just based on this. So we've got some color passing through all the clones and a bit of rotation. We could even add a bit of kind of position motion as well, and this gives us something rather unique. If I give myself a bit more time here and just let that develop over a few more frames. So the power in this comes from that Python tag. If I just open it up, you can see it's not that scary at all. It's all we're doing is just getting the object that the Python tag is on, which is the cloner. And then we're grabbing our user data, which is the angle and the count values. And then all we're doing is assigning this property on the cloner, this one here, to the count. And then I'm taking the end angle and just saying, wait, well, that just needs to be the count multiplied by the angle value. So all the steps that we were doing manually have been automated using this Python script. But we can take it a little bit further, of course. So I've taken that prototype from before and moved it along a little bit. And if I just render the view, you can see that now we're getting a different look to our Fibonacci spirals. We're now using a matrix object, and what's good about this is we can generate thinking particles if we want to, but everything just works because the matrix object has very similar properties to the cloner. So if we look at the Python tag now, the controls have been updated a little bit to include a few more fields. Notably is the radius, which we can control. We can increase that, and it will adjust the radius value on the matrix, but it'll also affect the position property of the step effector. So if I just drop this down, and by having this linked here, it means I don't have to jump into the hierarchy or find it anywhere. It's available to me, and I can just jump into the parameter tab, and you can see as I manipulate that slider, the Z position is changing as well. The advantage of this as well is we can come into the effector tab and make any adjustments to the spline. So all those controls are available. Looking at the code, if we just double click on the tag, we haven't actually had to go to too much additional effort to create this setup. A lot of the additional lines you see here are really just adding user data at the top. And these two that we have here are simply getting that radius value, which is over here, and just applying it to the radius of the matrix. And then we're just taking a negative version of the radius and applying it to the Z position of the step effector. If we wanted to, we can use other objects in Cinema 4D, so we could mesh this, and that produces something pretty cool as well. I'm just going to disable all that because I really like the look that we have going on with the hair render in conjunction with these cloned spheres that are cloning onto the matrix. What I set out to do with this script was just to streamline the process of creating Fibonacci spirals, and what we've ended up with is a tool that can be used to create a little bit of art with the help of maths. Hopefully that example showed that a little bit of scripting can facilitate your creative process. Now, there's some other useful areas that you can look at, and they include the C4D base time. This represents a time value in Cinema 4D, the utils module, and these are just helper functions and classes, and the GUI module, which means you can do things with the graphical user interface. So a lot of my scripting experience to date has revolved around automating repetitive tasks, and that still continues to be the case, but I have made a few tools as well, and they've helped me expand my knowledge further because the challenge is greater. If we know where we are in time in Cinema 4D, we can actually affect time. So in this example, I have a little Python script for retiming MoGraph caches. So if I just press play, you can see that we're actually retiming this simulation. And if I open up the tag, you can see it is not a lot of lines, but I'm combining base time, which is just getting the minimum time and the maximum time, and I'm also using the range map function, which is from that utilities module. And anyone familiar with Espresso has probably used the range mapper in there before. It's a really similar function here, and all we're doing is remapping this retime slide value to the min and max time. I was banging my head against the brick wall on this one for a little while. What was happening for me was everything was working just fine, but because over the 90 frames that I'm looking at here, I'd get to frame 45 and then the retime would just loop back around, so I'd see double instead of just a single playback. So I came across Dan Fitzgerald's blog, Curious Animal. There was a similar example which showed the need to offset the time. So that's what this value does here. So we're setting an offset. That is what I needed to add into my range map result and put that back onto the MoGraph offset value here. And once that's done, you end up with the retime that works exactly as intended. So then I took a look at Python generators and ended up building this knitting generator, or spaghetti generator might be a better name for it. What it will do is it will take the geometry underneath and try and create a spline that's based along the points that you give it. So if we just look in our objects list, we'll just drop in a torus and we'll take the plane out and just give ourselves a bit of room here. You can see this is still all procedural. We can adjust the properties of the underlying geometry and get a visual result in the viewport. Then there's some controls here just to adjust the tightness of the curve, and we can show the object itself as well, close up the spline. There's a couple of other cool things here which we can demonstrate with the disk. So let's just bring that into our list here. So with the disk, you can see that we've got this point in the middle. If we have a look at that, there's always going to be a point here. And so we can cull certain points. So if I just type 0.0, that is our first point here, so we can get rid of that. And what I'd like to do is be able to have a whole range of numbers here in maybe square brackets and separated by commas, something like that, but that's something to develop further. Next thing was to actually work with selections. So on the simple plane, if we just have a look at this, what I've got is a point selection. I'll just show the object. Just load up that selection. You can see might be a bit difficult to see, but there's some orange points selected already. And so I'm just going to hide the object once again and drag that point selection into the selection field. So there we have it. We can generate those point selections and use them in conjunction with this generator. And this comes into play with things like the Voronoi fracture. So if I just add that in and just grab that one. So now we've got a real mess really, but I learned a whole lot from making this. That's the exercise really. Opening up the expression editor, we can see that this is a lot more involved than the other scripts I've been working on, and I'm getting into point selections and things like that, and the modeling commands in the utilities module. These are so useful, and that allows for the procedural nature of this whole thing, meaning everything's still parametric. If we choose to use a parametric object, then it's non-destructive to that original object. And so yeah, this was a great learning experience to make this, even though it is a little bit silly. And lastly, in this little section, I just want to talk about another script that I took a little bit further. So I've got my script manager. I'm going to find my Espresso null plus, so I'm going to drag that into the interface. This is that first script that I wrote a while ago, but just with some additional functionality. So now we're getting into the GUI module, and by doing so, we can listen for certain commands. So if I just click, this is going to give me that Espresso, just the original functionality. But if I hold down Alt, I'll get a null with a Python tag on. If I hold down Control, I'll get a null with a user data tag on. And if I hold down Shift and click, I can choose to name certain dividers. So if I call this lights, shift click again, get all my cameras. And if I shift click one more time and just don't have a name and choose OK, then I just get just a basic divider, which I can use to reorder my scene into these group nulls that allows me to kind of organize my hierarchy in a more meaningful way with less clutter. I'd now like to talk about field forces, and I've been having quite a bit of fun with these recently, working with thinking particles to generate particles that will flow over the surface of geometry. We can do that with multiple particle sources, and there's some really cool things that you can do with volumes and dynamics in conjunction with field forces as well. So we want to achieve something like this, where the particles are flowing over the geometry. If I just pause the playback and just render the view, you can see we've got some pretty cool looking effect happening here. We need to understand how the thinking particles were talking to the field force object in the first place. And it's a very simple setup, but it's just a few steps. So let's just break that down. In this new scene, I'm going to create a matrix object. A matrix can generate thinking particles, so we'll set it up in that way. And then I'm going to hide the matrix object. Next, we can add a null object with an Espresso tag on there, and I've got a script that will do that automatically. And we're just looking to create a couple of nodes that will get thinking particles to talk to a force object. And I'm going to right click and choose thinking particles TP initiator and grab a P pass. And that's going to pass everything into whatever we choose next. So that's the all group. Next, we're going to add a TP dynamic P force object. And this doesn't have anything in here by default. So what we need to do is come over to simulate. In our forces list, we can actually add any of these, but we're going to focus on field force. So we'll add one of those to the scene and then just drag and drop it onto where it says none here. And that's just like dragging it into the object field in the attributes manager. I'm going to connect these up, and that's it. So all we need to do now is grab our field force object and add a field to the object tab. So when we do that and press play, you can see that we've kind of created an attractor with this spherical field. And we can move this around and the particles will follow it. That's the basic setup. And so I'm going to just build on this with a new scene. That's just too many steps for me to go through again, so I've automated this onto a script using Python, of course. And so now I'm ready to go. I'm going to get some geometry in the scene, such as a torus, and we're going to bring this in and we're going to make our matrix generate not a grid, but onto an object. And so we're going to generate those thinking particles onto the torus. The surface is fine. We're going to bump up the count to something like 2000. Now, the remaining particles are still in the scene, so all we need to do is go forward a frame, press G, and press F to go back a frame. Okay, so now we're going to use the torus to generate some vectors in conjunction with a volume builder. I'm going to add the torus as a child. We need to change the volume type from sign distance field down to vector. Now what this is doing is generating vectors based on the geometry that we provided, and you can see that we have vectors pointing in different directions based on the normals of the geometry. So some are pointing this way, some are pointing outwards, and to demonstrate that, let's just drag this volume builder into the field force object, and we need to make sure it's a volume object. We can rewind and press play, and you'll see that, yeah, some pretty crazy stuff's happening. To get this a bit more under control, what I'd like to do is come back onto the volume builder and just start to make these vectors line up with the geometry. I'm going to do that with a random field because I also want to randomize their positioning. The advantage of using a random field is that we have lots of different noise types and they produce lovely surface flow patterns. If we just zoom out, you can see that we've got this box of randomness. All these vectors are just pointing in different directions and we want them to be taking the shape of the torus object. So if we click onto the random field, we can change the creation space from box, which is this 200 by 200 by 200 box, to objects below. So with that done, we can see that the vectors are still going everywhere, and this will produce something interesting, but not what we want. The particles are escaping everywhere. To bring that under control, it's just the way that the vectors are being added together. We can change this to cross, and you can see that now that's actually following the surface. They're still going to escape if we press play. And the reason for that is because the field force object, we're setting the velocity type to add. So we're adding to the velocity on every frame. And so we want to actually change this to be an absolute velocity. So we can crank this up to like 200 and just see what happens. And now you can see that the particles are kind of jittering around and doing some crazy stuff, and it might be easier to visualize this with a tracer. So I'm going to select the matrix because I want that to be the trace target. So we're going to create a tracer, rewind and press play. And we're getting some really jittery motion here. On the volume builder, there's a couple of options that we have. And we can change the voxel size. If we bring this down to like 2, we can see how tight those vectors are now. We can rewind and play. If I hide the visibility of that, we're getting something pretty cool. I'm going to actually come into our thinking particles settings, come into there and just change this to dots and just give it a kind of pinky color. And you can see hopefully a bit more clearly what's going on here. We can also adjust the random field to like 1000 if we change the scale to 1000. This adjusts the flow again. And then the other thing to experiment with again is the voxel size. So if we bump that up to 20 and just rewind and play, we'll get something different as well, slightly more angular looking. What I think I'm going to do is just drop that down to 2 again and just rewind and play, and I'm pretty happy with that result. If I give myself some more frames, those particles are really flowing over the surface quite nicely. And then it's just a case of experimenting with different noise types to get different patterns. So in this scene, we're going to talk about how we can use different forces with field forces and thinking particles. If I just open up the Espresso tag, you can see I've got a gravity of it's just a duplicate of the P-force object node with that gravity object in there as well, and all the particles are being passed onto that. Gravity is going to make the particles fall, and then the field force is actually going to stop the particles in their tracks because we're setting an absolute velocity to 0, but there's nothing in here. Oh, that's where the fall off tab comes in. So I've used a volume builder to generate vectors based on a landscape object, and this produces some interesting results. If you come back onto the field force, the box field is here just to stop anything from escaping. So if I just rewind and press play, you can see now that we're kind of generating a little sort of future UI element here, which is pretty cool. And something I discovered recently is the vector normalize layer. So if I turn this on and rewind, what this is going to do is it's going to kind of normalize the vectors. So we'll get a kind of stair-stepping effect like this. So that's even cooler in my opinion. I like that, and it's a nice discovery. In this example, I've got multiple sources, and that's fairly simple to do, just using a connect object with these different disks underneath, and our matrix is just generating onto those sources. The containment of this is being handled by field forces as well. So all we're doing is using a torus object to capture them, and we're changing their direction so they'll bounce off the inside of the surface of this geometry. So it's just a case of dragging in some geometry and just setting the mode to surface and then restricting the effect to be the inside of that surface, and that gives us the result that we see in the viewport here. Finally, I'm just going to talk about this cloner that we have here, and it's doing some pretty fun stuff, almost like an emitter itself, and this was set up with a little bit of Python scripting, well, not too much, and I've got some controls here just to change the emission type as well. This was really a fun experiment to just kind of see if we can do this with just making a cloner like an emitter. So we can adjust the count and the frequency of the count, so we can kind of almost create a pulsing effect. If we change it down to like 1, we'll get streams of particles generated. Another option is just to bump up the amount and limit it down to something fairly low, and just let it develop like so. Now that's giving us this nice motion because of the friction that's in the scene, and each object that's being generated has a dynamics tag on it, and I've got the script set up in a way that if I add an object to the list like so, it's going to think about it and then add a dynamics tag onto it. And this bucky shape that I have here is fairly complex, so if I just rewind and press play, and you can see now we've got some pretty crazy collisions happening. But yeah, this was quite a fun thing to set up, and so it just leaves me to say that through experimentation and kind of building on the tool set that's already in C4D, we can use Python scripting to take the regular tools a little bit further. It's just a lot of fun once you get over the initial hurdles that are there at the beginning. And so I'd like to just direct you back to some learning resources that can help with getting started. So on screen we've got a list here of some useful blogs and a fantastic course from FXPhD, but really the Python SDK is where you're going to be getting a lot of information from. And you can see there's a resources section even in the SDK, which is fantastic. I started a Slack group, C4D Python, quite a while back when I was getting into this, and we've got 106 members currently, so please join there if you want to join the conversation or maybe get some help with your coding. I want to thank all the people that have helped and inspired me on my Python journey so far, whether this is known to them or not, but it's because of them that I'm not afraid to get into the expression editor and try out some ideas. I really do see what you can do with coding as just another form of creativity. The X Particles Challenge is a competition I organise and have run since 2015. To me, it's very much like a personal project, and I'm so proud that people keep entering each year. I want to say a big thank you to the judges who helped me decide the results, and to our amazing sponsors. After each challenge, I cut a showreel of all the entries, and I'd like to play that for you now, with music and sound design by Zelig Sound. So thank you for your time and attention. I really appreciate it. And thanks again to Maxon for giving me the opportunity to talk to you. Once again, my name is Andy Needham, and you can find me online at I'm Called Andy.